Hey, Chemsters, this is Mrs. Vandaloy bringing you more notes from Chapter 1. We're going to finish up Section 1.2 with this. So we've been talking about physical properties, chemical properties. Now we're talking about physical and chemical changes. They're very similar, the idea of the properties, but the idea is that the properties of material changes in both cases, and the physical change, the composition does not. In a chemical, the composition does change. So what are some physical changes from the demo day? Well, what was the very first thing we did in demo day? We looked at the magnesium ribbon. And do you remember what I did with the magnesium ribbon? The first thing I did is I ripped it into some pieces, didn't I? I just used my fingernails and I ripped it. Another thing I did, if you recall, is that I took it and I flexed it. I bent it. We said it was malleable. So that would be a physical change, just bending the magnesium. What else did I do in the second one, the film canister? I took that ethanol and I heated it up with my hand and I evaporated it. So it is still ethanol, it just went from a liquid form to a gas form. What are some other examples of physical changes? Well, probably a very common one, especially on a nice hot summer day, would be melting ice. So it goes from a solid form to a liquid form. It is still H2O. Here's one you may not have considered, dissolving sugar. So when I put sugar in water, is it still sugar? The answer is yes. It's just in smaller chunks. So the idea of a physical change is that you're just changing location. You're just changing the arrangement. You're not changing the actual composition. So think about this. I'm ripping into pieces. I'm bending it. I'm just changing location. I'm evaporating it. I'm going from a liquid to the gas. I'm changing its location. Melting, I have a nice strong structure like an ice cube, and now it just blobbed all over the place. It's changed location. So is dissolving. Physical changes can be described as reversible or irreversible. What can I put back? If I rip magnesium into pieces, can I get the magnesium stripped back? The answer is no. So this would be irreversible. Bending magnesium, reversible. I can get it. If, as long as I don't break it, it will bend back. What about evaporating? Can I cool down that gas and get a liquid back? Sure can. What about melting the ice? Can I cool it down and get the ice again? Sure can. That's reversible. Well, dissolving sugar, can I get that sugar back? Sure can. I can just evaporate out the water. And that's how you make rock candy. So it sure can. So a lot of them are reversible, but not all of them. So something to think about. What about chemical properties and chemical changes? So a chemical property relates to the ability to undergo change that makes a new substance. So a chemical change is a change that produces matter with what? Underlying this, different chemical composition. So do you remember from demo day, I started out with this nice silvery, shiny piece of metal. I burnt it with magnesium or with oxygen. And what did I get back? I got that white, brittle, granular powder. All right, I changed its composition. So how would this work using a particle diagram? I'm going to let, and you might want to jot this down, these blue circles be my magnesiums, and I let the little red circles be the oxygen gas. So what happens? The composition changes. So when you have that chemical reaction, when you have that flame, that spark, that energy, it's going to break some bonds. It's going to break the oxygen bonds. It's going to tear these guys apart. And what's going to happen? They're going to rearrange. Here's one magnesium oxide. Here's another magnesium oxide. So I changed its composition. I changed the way it was bonded. All right, so what about here? When physical or chemical changes take place, energy is always involved. So what are some examples from demo day? Well, I seem to have energy in every single one of those, didn't I? I'm not going to type this out for you. You can write this down. I had the light, that bright, bright light with the magnesium. I had that heat from the ethanol can, the film canister. Well, even though my coffee can didn't work out too well, but oops. What about the chemiluminescence? All right, that would be another example from a demo today. Actually, I guess I could do this. Burning magnesium, burning the ethanol. I guess I did have it written down. The coffee can was burning methane. I'll get it right here. And then the chemiluminescence. Those are all examples of energy changes. So burning, they had the light. Burning had the heat. Burning had the flame. Chemiluminescence had that color. So other examples, I guess you already saw it, rusting. You'd go from nice iron to rust. You are changing the composition, and even baking bread. Think about it. Well, if you have bread, you typically have yeast in it. The yeast is producing a new substance called carbon dioxide, and that's what makes it nice and spongy. All right. So those are other examples that you have energy involved. Rusting, it does require energy. Baking bread, it requires heat. So there you go. Let's see what the next page is. All right, so all matter can be a pure substance or a mixture. So let's talk about mixtures first. Mixture is a physical blend of two or more substances, can be physically separated. How do you put them together? Physically. So if you think about it, what two things can you physically put together? Well, how about this? Salt and pepper. Can you put those two together? You get the salt shaker out, the pepper shaker out, and you blend them together. What about oil? Oops, wrong one. How you just saw that one, didn't you? Oil and water. So can you pour some oil and water together? You physically put them together. Can you physically separate them? Yes. Here's one I like is iced tea. I love iced tea. So can I physically put them together? I put my tea bag in, I put my water in, I put my ice cubes in, and voila, there I have iced tea. Now we can have heterogeneous or homogeneous mixtures. Heterogeneous means a mixture that is not the same throughout. Okay, so some of my came up with sand and water. If I have a bottle with sand and water in it, they're going to separate out. The sand's on the bottom, the water's on top. How about chicken noodle soup? You can definitely see the chicken and the noodles and the veggies, all right? Here's a good one. Grater's double chocolate chip ice cream, all right? Is it uniform throughout? No, I love those chocolate chips. So they're not the same. You can actually see the different parts to them. We have homogeneous. There are mixtures that is uniform throughout. So milk, you don't need to shake up your milk. It doesn't separate out, does it? Tap water, there are things in your tap water. You have, chlorine and fluoride and dissolved gases and some minerals, okay? But, it's uniform throughout. You don't see all those things. Just clear chicken broth, okay? You don't see little chunkies floating around. It's just, chicken broth. And here's another thing to think about, air. Is air a mixture? Yes, it is. It has, oxygen and carbon dioxide and water vapor. It is uniform throughout. You don't need to, shake it up or anything. The air here is the same as the air, someplace else, in Michigan or someplace. So it is the same throughout. Now, if we have water present, it's also called a solution. So this could be a solution because you have water in the milk. Tap water is a solution. Chicken broth is a solution. I don't think air necessarily is, because when we talk about water, we're talking about liquid water, not gaseous water. Mixtures can be separated. Okay, we said that up here, can be physically separated. And this is a lab that we're going to do on Friday. So we're going to separate a mixture using some of this equipment, not all of it. But we have things called filtration, distillation, and using a separatory funnel. So what is separating in filtration? A solid and a liquid are separating. What happens here is that you collect the solid into the funnel, the piece of paper in here. The solid is in the paper and the liquid comes through, so solids and liquids. In distillation, you are using the property, they have two different boiling points. So you have two liquids at two different boiling points. You heat it up, and the one at the lowest boiling point becomes a gas first. You cool it down and drips, drips, drips here. So the lower boiling point liquid's here, the higher boiling point remains in here. A separatory funnel is when you have two liquids that normally don't dissolve in each other, like oil and water. So like I said, we're going to use some of this equipment on our foul water lab. So we'll be using a filtration, and we'll be using a separatory funnel to physically separate the mixtures. Okay, let's go on to the next page. So there are two kinds of pure substances. What they have in common is they have a fixed composition. It says every sample of a given pure substance has exactly the same characteristic properties like melting point and density and things like that. Pure substances are either compounds or elements, and elements cannot be broken down. So if you have carbon, you can't break down anything further and still be a carbon atom or a carbon element. Compounds can be broken down. You can heat them or use electrolysis, and that is how actually sodium chloride, they use electrolysis with that, and sodium came out on one end, the sodium metal, and chlorine gas came out on the other end, and that is actually how sodium was discovered by Sir Humphrey Davy, by using electrolysis. So finally, to put this whole thing together, everything is matter. So the question is, can the matter be separated by physical means? All right. If the answer is yes, then it is a mixture. And that's where we use the separatory funnel and the distillation and the filtering. If it cannot be separated, then we call it a pure substance. Okay. We can't further separate them apart. So next, let's look at the mixture. It is a uniform. And if you think of that prefix homogeneous, homo, it does mean the same or alike. So if you have a homogeneous milk, it's all the same throughout. If it's not uniform, then we call it heterogeneous, all right? And that would be your chicken soup, okay? Can a pure substance be further broken down? And the answer is yes. Then it's a compound, and that's what we use the electrolysis. Or your decomposition by heating. If you can't break it down any further and still retain its properties, then it's considered an element. And that's where we're going to quit today. I hope you had no problems filling out the notes. If there are any questions, you can always ask. So, folks, don't wait to be great. See you later.